This is for section 3.8 homework, question number 6. Where I'm gonna go ahead and click on similar questions so that I can start brand new. We're finding the second derivative implicitly. Oh, interesting. So let me go ahead and write down the problem and get started. So we have x to the third power minus 3y cubed equals 8. And the goal is to find the second derivative y with respect to x. All right, so let's find that. I will differentiate both sides implicitly first. All right, so x cubed minus 3y cubed on the left side and 8 on the right side. Right side is just 0, right? This is just 0. Derivative of a number is 0. The left-hand side, let me separate them. I'll do the derivative of the first term minus the derivative of the second term. All I did was just separating them. All right, let's go ahead and differentiate each of these. Okay, first, derivative of x cubed is simply 3x squared. Okay, now let's do this one. I'll copy down the minus sign. But when I take the derivative of 3y cubed with respect to x, it's not just going to be 9y squared, but I must multiply this by dy dx. And this equals 0. Now let me think. Okay, so I will solve this for dy dx now, okay? I will solve this for dy dx. So nothing different from what we did in class so far, right? It's all the same so far. So negative 9y squared times dy dx equals negative 3x squared. Okay, now I'm going to divide both sides by negative 9y squared. 9y squared. Okay, if I do that, this cancels out. I have dy dx equals, all right, let me simplify this. Negative 3 over negative 9 is positive 1/3. So derivative is x squared over 3y squared. Now, we have to go on one more step. They wanted the second derivative. I found the first derivative. So we're going to go on. Now, if you notice, this is a quotient. So we're going to have to use the quotient rule. So using the quotient rule, which says the derivative of this, miss, is going to be the bottom times gf prime minus fg prime all over g squared, where f is the function on top, so f is x squared, and g is the function in the bottom. Okay, so let me find my quotient rule pieces. F prime is 2x, g prime is 6y times dy dx, because we are differentiating with respect to x in this whole problem. All right, let me put my quotient rule pieces together. The second derivative of y with respect to x is, I have to do g f prime first, right? So where's g and f? G is here, f prime is here, so I need to multiply those two together. So that will be 3y squared times 2x. Okay, and then I need the minus sign. All right, what's the second piece of the numerator? I need fg prime. F is this, g prime is this. I'll multiply those two together. X squared times 6y times dy dx. Okay, cancel. Let me erase these real quick. all over, I need g squared. So I need to square 3y squared in the bottom, okay? So that will be 3y squared squared. Okay, now we're gonna have to simplify this a little bit, okay? Alrighty, so I have dy, well, the second derivative of y with respect to x is, the denominator is 9y to the fourth power. If I square 3y squared, then that's going to be 9y to the fourth power, right? So we're okay with the denominator. All right, let's look at the numerator. If I multiply these two and just put it in nice order, I will get 6xy squared. Okay, that's good. Next, I have minus x squared. Oh, hold on. I'm trying to simplify this. Okay, I'm trying to simplify that. But hold on. We know what dy dx is. So how about we simplify this on the side over here? This is x squared times 6y times, what was dy dx? Remember we found that the first derivative is this, right? So I'm multiplying this by x squared over 3y squared. Let's see if we can simplify this, okay? I plugged in dy dx back here. So if I try to simplify this, I will have, first, you notice that we have 6 divided by 3 here, right? So that's going to give us 2 on top of the fraction. And I'm multiplying what? X squared times x squared. That's going to give me x to the fourth power on top of the fraction. But if you notice that we are doing y divided by y squared, that's going to give me y in the bottom of the fraction. It looked really good until we have that y in the bottom. So the second piece of the numerator is 2x to the fourth over y. I mean, this is correct. It's just as ugly because it's a fraction over fraction. So I don't know. If I type this in, I think that's gonna be okay because that is the second derivative. It's just not as pretty as I want it to be. So let me type this in, and if they tell me, Sue, you need to simplify, I will. But for right now, we found it. So I'm just gonna go ahead and type this in to see what they say. Minus 2 over, whoopsies. The numerator is 2x to the fourth over y. Yeah, fraction and a fraction is not really nice, but hey, it is what it is. So if they say no, you need to go on further, I will. But hold on just 1 second. Let me click on, oopsies. Let me click on check answer. Yeah, so that was okay. So I guess we can simplify this further by separating this and, simplifying the fraction of a fraction. But hey, you want to see? Yeah, I'll do that. Why not? So I can simplify this into 6xy squared over 9y to the fourth minus, all right, the second piece is going to be like this, 2x to the fourth over y divided by 9y to the fourth. You know what I did, right? I rewrote this fraction first. Okay, so that's that one. And then I also did this divided by 9y to the fourth. That's this piece right there. All right, let me try to simplify, but you don't really have to watch this part because we already got the correct answer. But if you just want to go on and write your answer in a really pretty form, you can continue watching. So I have 6 over 9. That's going to give me 2 over 3. There's just x on top, but I notice there is y squared divided by y to the fourth. That's going to give me y squared in the bottom. So that's the first piece simplified. Minus, I have 2x to the fourth over y. Now I'm going to change it to keep change flip and make that second fraction, second 9y to the fourth, a 1 over 9y to the fourth, because I changed it from division to multiplication. Right? I keep change flipped it. So 2x over 3y squared minus, if I combine the second fraction together, I will get 2x to the fourth on top and 9y to the fifth in the bottom. We can go on further too. Yeah, we can. If you want to write this into a single fraction, what I can do is I can multiply the first fraction by 9y to the third. I don't know why I'm doing so much extra, but if you're just interested in writing a pretty final answer, why am I multiplying by 9y to the third? I'll take a look. Because if I do that, I will get 6xy to the third on top, all over, 9y to the fifth in the bottom, right? And now they have a common denominator. They have a common denominator. So I can write this as 6x to the times y to the third minus 2x to the fourth all over 9y to the fifth. So what was difficult about this problem? That it was a second derivative problem, that you had to plug in dy dx to find the second derivative answer in a simplified form. And we just did extra work just to simplify our answer in a pretty form. But this green circle part was, oh my lab, really, I guess, expected or wanted. But that's how you can do this question. And this one was homework section 3.8, homework question number 6.